It's something billions of us deal with every single day. Some people see the world in perfect, crisp, high definition, while for so many others, it's, well, a bit of a blur without some help. So today, let's get into the amazing science behind why our vision isn't always perfect and what it takes to bring the world back into sharp focus. It really all boils down to this one question, and the answer starts with the journey of light. When light travels from, say, a tree and into your eye perfectly, you see a crystal clear tree. But if that light takes even the tiniest wrong turn inside your eye, that's when your whole reality starts to look a little fuzzy. Okay, so before we can unpack what goes wrong, we've got to understand what perfect vision even looks like. There's a scientific name for it, and it's our starting line, our gold standard. And that name is Emmetropia. Fancy word, right? But all it means is that light rays are entering your eye and focusing with absolute precision right onto your retina. Just think of the retina as the movie screen at the very back of your eye. For a clear picture, the image has to land perfectly on that screen. And this whole thing happens in a blink of an eye. It's like this incredible little relay race. Light hits the cornea, gets passed to the lens, which makes the final perfect adjustment, and bam, the image lands flawlessly on the retina. Your brain gets a perfect high-def picture to look at. But for a huge chunk of the population, that perfect little path gets messed up. The light gets bent just a little too much or not quite enough, and that's when the world starts to go out of focus. This right here shows you exactly what's going on. On the left, you've got that perfect focus, but on the right, that's what we call a refractive error. Instead of a single sharp point of light hitting the retina, the light either overshoots it, falls short, or just gets scattered all over the place. And this is the one term that explains why so many of us need glasses or contacts. Ametropia. It's just the official catch-all for when that journey of light goes a little bit sideways. So let's break down the most common ways this happens.
All right, we're going to start with the two big ones, the ones pretty much everyone has heard of, being nearsighted and farsighted. They're basically opposites, but they're both caused by that same core issue, light just missing its target.
So first up is myopia, what we all call nearsightedness. If you can read a book just fine, but the road signs down the street are a complete blur, well, this is probably you. What's happening here is the eye is focusing the light too much, so the image actually forms in front of the retina. The most common cause? Your eyeball is just a little bit too long. Sound familiar? Squinting to see the TV? Getting headaches after a movie? Maybe having to sit in the front row at school just to see what the teacher's writing. Yep, those are all the classic signs. And the solution is actually pretty cool. A concave lens, one that's thinner in the middle, spreads the light rays out just a tiny bit before they even get into your eye. This basically cancels out your eye's tendency to overfocus, pushing that focal point right back onto the retina where it belongs. Simple, right? Now let's flip the coin and talk about the mirror image, hypermetropia, or far-sightedness. In this case, distant stuff is clear, but anything up close is a blurry mess. This happens because the eye's focus is too weak, so the image tries to form behind the retina. And often, the cause is the exact opposite too, an eyeball that's a little too short. You'll recognize this if you get headaches after reading for a while, or if you find yourself doing that classic move, holding a menu or your phone as far away from your face as possible just to get it into focus. So the solution here is, you guessed it, the opposite kind of lens, a convex lens, which is thicker in the middle, bends light inward. It gives your eye that little extra focusing boost it needs to pull that focal point forward right onto the retina. It's just a beautiful bit of physics. But hey, it's not always as simple as just near or far. Sometimes the problem is more about distortion. And then there's the one thing that gets almost all of us eventually, just plain old aging. This brings us to astigmatism. With astigmatism, the problem isn't so much where the light focuses, but the fact that it can't focus in one spot at all. This is because the cornea or lens isn't shaped like a perfect sphere, like a basketball. It's shaped more like a football. This wacky shape scatters the light, creating multiple focus points and distorted vision at any distance. And you can't fix a football-shaped problem with a simple round lens. You need something specialized. That's where a cylindrical lens comes in. It's engineered to correct for that specific weird shape, bending light in one direction but not the other to pull all that scattered light back into one clear single point. And finally, we have the one that's basically inevitable, presbyopia. This one isn't about the shape of your eyeball, it's all about the lens inside your eye. Over time, it just loses its flexibility, kind of like an old rubber band. It gets harder and harder for it to change shape to focus on things up close. So, what's the magic number for this? Well, for most people, it starts to become a real nuisance sometime after age 40. It's that moment you suddenly realize your arms aren't long enough to read the fine print anymore. Okay, so we've got nearsighted, farsighted, distorted, or just aging eyes. These are all the different ways that perfect journey of light can get sidetracked. So now let's pull it all together and see how we bring our world back into focus. This chart just lays it all out so clearly. You can really see the elegant pattern here, right? If the image forms too close, we use a lens that spreads the light out. If it forms too far, we use a lens that brings it together. And if the image is all scattered, we use a special lens to gather it all back up. For every single problem, there's a specific, brilliant solution. And today, we have way more tools in our toolkit than ever before. Glasses are still the classic go-to, but contact lenses give you a whole different kind of freedom. And if you're looking for something more permanent, surgeries like LASIK can actually reshape your cornea, or you can even get a brand new lens implanted in your eye. And here's the thing. This all matters so much. Correcting your vision isn't just a minor convenience. It's about stopping those chronic headaches and eye strain. It's about being able to learn effectively in school, do your job well, and just navigate the world safely. Seeing clearly isn't a luxury, it's absolutely essential. So it leaves us with a pretty fascinating thought. As our technology gets more and more advanced, are we heading towards a future where having blurry vision isn't just a fact of life, but an optional problem? A future where seeing the world in perfect high definition isn't a matter of genetic luck, but a choice that's available to absolutely everyone? It's kind of an amazing thing to think about.